Okay, fantastic. So our next speaker is Jasmine Tan. She graduated from King's College London, United Kingdom, with a Bachelor of Music in Music, and went on to do a Master of Science in Music, Mind and Brain at Goldsmiths, University of London, United Kingdom. Her particular interests are in neuroimaging and music cognition. Under the supervision of Professor Joydeep Bhattacharya, our previous speaker, she is finishing a PhD in psychology at Goldsmiths on the neuroscience of flow and altered state of consciousness resulting from intense engagement in a challenging and enjoyable activity. Thanks a lot, Jasmine.
Thank you, Amir. Shall I share my screen? So hi, today I'll be talking about how we discuss how we study the neural correlates of flow. So first off, let's talk about, do you experience flow? So have you ever done anything where your concentration is so intense and your attention is so undivided and wrapped up in what you're doing that you become unaware of things that you normally notice, such as being tired or hungry or other people talking? Do you ever do anything where your skills are so second nature to you that everything just seems to come naturally or effortlessly? And finally, do you ever do anything where even if you don't get any other benefits from it, you feel that the activity is worth doing in and of itself? If you can answer yes to all these questions, you probably have experienced flow. So I chose this description because it's from a composer and it seems relevant to this audience. So he describes an ecstatic state that to the point that you feel that you almost don't exist, and he just watches the music flowing out of him. So it's an optimal experience, a psychological state involving the positive experience of being fully engaged in a successful pursuit of an activity. People have found it in musicians, surgeons, and sports. So characteristics of flow include challenge skill balance. I will speak a little bit more about that later. Action and awareness merging, in which you feel that what you think and what you do seems completely congruent. Flow often appears when you're in a situation where you know very clearly what you want to do and you have a very clear feedback on how close you are to your goal. And you're often fully concentrated on the task and you feel a sense of control. You lose self-consciousness. And you often perceive the time is transformed, like maybe it's moving faster or slower. You might have looked up and suddenly hours have passed, or you will look up and find that much shorter time much has happened in a much shorter time than you expected. And finally, it's an autotelic experience. It's a long word, but it just simply means that it is an intrinsically rewarding experience. So the experience exists for its own sake. So we'll focus particularly on the first one, challenge skill balance, because it is a core structure on how we design flow experiments. So it's quite a simple, intuitively understood concept. When the task is too difficult, you're anxious. When the task is too easy for you, so the demands of the task are much lower than your skill levels, you are bored. So flow is this happy middle where you experience the perfect matching of your skills and demands. So we often see this behavior in physiological signals and attention, where you find it peaks in flow. It is low in both boredom and stress. So when something is too difficult, you are not fully paying attention, and when something's too easy, now you're also not fully paying attention. And flow is that perfect middle. So whoops, sorry, I'll come back to that. So most of the time we study flow in the lab. So we study, excuse me. So we study flow in the lab by working on that challenge skill balance I've just described. So the one experiment gave people mental sums, so mathematical sums, and adjusted their difficulty levels. Other people use games, such as Pong and Tetris and Pong. So they have found that it is associated with increased activity in brain regions related to a sense of cognitive control and decreased activity in self-referential processing. And the brain activity also follows the inverted U-shaped curve, where it's highest in flow and lowest in boredom and stress. But obviously, these I wouldn't want to say that you couldn't experience flow in these activities, but it does sound really distant from the experience described by musicians and sports people. So we would like to actually look at flow in activity that is well known to cause flow, to cause flow, i.e. music. So music is a naturalistic flow-inducing activity. It has been used to study the physiology of flow under lab circumstances. We often study it in musicians in relation to motivation to take part in music, in their practice efficiency, and music performance anxiety. Dispositional flow is what we call is the term for the tendency to experience flow. So we all have we're differently able to experience flow. So it seems that, so a previous study in our lab found that the tendency to experience flow in musicians is affected by their trait emotional intelligence. And we did, it was hypothesized that it is because music, as we've heard in the previous presentations in the past few days, that music is an emotional activity. Music is very much, emotion is all wrapped up in music. So being able to effectively process and handle emotions might help us better experience flow in it, because it enables us to meet the challenge of the situation. So again, we're not really, but again, the music, these studies are often conducted in versions of questionnaires where we ask musicians how often they experience flow, but we want to see what music is like what the brain looks like in flow. After all, being able to study flow in the brain would let us understand the mechanisms behind this phenomenological experience. And it would be ideal if we could have a way to measure flow that doesn't require us to interrupt people in flow. So this is what we tried to do. We brought musicians in the lab. So we brought musicians in the lab, and it is kind of what it looks like. So we wanted to use actual music to closer approximate the experience of flow, and it would not, and although this does not offer as much control as the other experiment, it seems more ecologically valid. So we brought people into the lab, we had them wear the EEG caps, and while they played music. So they brought two familiar and fluent pieces, one that induces flow and one that does not. And we had them repeat it 3 times just to see whether we could get some kind of stable response. And to ensure that we get data to measure, because the brain is has a less strong signal than the muscles around the face, so it will be disrupted by playing. So to ensure that we get some clean data to record, we tried to get a measure of the experience as close to the actual playing as possible. So we asked people to close their eyes for some EEG recording for 1 minute right after play. And participants completed a flow state scale, which is a measure of the 9 different characteristics of flow that I introduced earlier after every single piece. So we measured 64 channels, and we also recorded all throughout the experiment, including the resting states. So what do we find? We did find that self-reported flow is higher in flow pieces than non-flow pieces. So it's a significant difference, which is so it gives us some confidence that musicians are effectively inducing flow in themselves in the lab. So when we looked at the brain data after the experiment, after the playing, we found that there was significant differences in these ranges of brain data, so in brain and frequencies. So alpha and upper alpha 10 to 12 hertz and beta 12 to 30 hertz. So in this picture, this is a measure of power, and red means that it was higher in flow, and blue means it was higher in non-flow. So we found higher alpha and beta power in flow, What could this mean? So alpha oscillations reflect inhibitory activity. So the more alpha oscillations are, the less active your brain is, which is really interesting, especially in relation to where we found the alpha, because there's a theory of flow that suggests that it is a case of transient hypofrontality. So with less so it is a case of the explicit system in the frontal lobes being suppressed to allow the implicit system to execute well-practiced actions. So increasing alpha power has also been related to better cognitive performance, better focus and concentration, and more creativity. It is quite interesting that we have also managed to find that our results somewhat match one of the experiments, one of the more experimentally controlled experiments where we're using mental arithmetic. So they also found frontal central alpha rhythms in flow. Increased beta activity might reflect post-processing of successful motor actions. So beta oscillations have been found to be larger following correct actions than wrong movements. And it seems plausible that there might have been more correct actions in flow than in non-flow, in the non-flow piece. So this may reflect an ease of performance in flow. We can also measure how information is transferred in the brain during this state. So this might be a little overwhelming, but basically it is showing how electrodes, so different parts of the brain, transfer information to each other. So if it's a red plot, it means that information is being sent by that electrode, while the blue plots will show that the information is being received. So this will be a slightly easier picture to understand. So we are finding that in flow, but when we compare flow and non-flow, there are significant differences in our right frontal cluster. So in flow, information is being from the frontal electrodes. The right frontal electrodes are driving the electrodes at the back and central areas, whereas in non-flow, the information is coming from the back, the temporal regions to the frontal areas, the right frontal cluster instead. But it's quite interesting that this is only for people who are high in dispositional flow. So we only found this pattern when people are already well disposed to experience flow. So we also want to look at other possible brain neural correlates of flow. And one thing what we wanted to look at was the second factor, which is the action awareness, which is our action awareness merging in flow. So this is because our bodies we often report a different experience of our bodies in flow. And we wanted to look at interoception, which is the processing, representation, and perception of stimuli originating from within the body. So people report the altered experience of the body during flow. They say you don't think of yourself as separate from what you're doing. They describe feeling at one with the movements you're making. They describe being really strongly aware of internal states like heartbeats, muscles, and you feel like you're bigger and stronger and you're fitter. So could this be an increased interoceptive awareness in flow? One way to look at it is that there is a brain response called the heart evoked potential, which is time locked to the heartbeat, and it reflects individual differences in interoceptive awareness. So what we do is we take people's heartbeats, we measure their heartbeats, and then we time lock it to the neural response as well. So we'll slice up the information, we slice up the brain data, time to the heartbeats, and we get a brain signal that is a representative of how aware is a record of the signals from the cardiac system. So it has been found that larger negativities, which is more negative, the more negative ERPs are linked with better interoception. So we brought people back into the lab, except this time we asked them to bring 3 pieces because we wanted to differentiate between two additional aspects of flow, which is the challenging part of it and the enjoyment of it. So we asked people to bring 1 flow-inducing piece and 2 non-flow inducing pieces now. One that is equally as challenging as the flow piece and one that is equally as enjoyable as the flow piece, but they do not experience flow in them. So we did find a small but significant difference in subjective experience. Again, they responded on their flow experience. And the differences are mainly between the flow and the non-flow conditions, but they are pretty small. Because again, these 2, enjoyment and challenge, are integral parts of flow experience. So controlling for one of them means that we are reducing the difference in experience. So we did find, so we looked at we took a general average of all the HEPs across the brain, and we are finding that there's a bigger amplitude in flow. Due to convention, ERPs are presented so that the negative, said that the negative part is on the upper part of the brain, so it looks flipped. So this larger thing is a larger negativity. And it is quite positive. It's quite interesting to see that flow is very distinctly different from the non-flow conditions. Looking at the mean HEP amplitude across the brain, we are finding that the biggest differences are in the frontal areas. Mainly the frontal part of the brains, as we found in the previous study as well. So there's a larger negative amplitude, especially in the frontal regions in the flow conditions than the non-flow conditions. What could this mean? It could indicate better brain-body interactions, which may be the reasons behind the action awareness merging and the sense of control you feel in flow. It could also be a result of emotions. So flow could be an increased emotional experience. So the interoception has also been linked to emotion and emotional processing. Now, flow, of course, so music isn't the only activity you can experience flow in. So we are also looking in climbers. So this is an ongoing experiment that was unfortunately interrupted by the whole virus situation. But we wanted to look at rock climbers because they also report experiencing flow. And we wanted to examine the traditional flow experiment, i.e. challenge skill balance from in a real world setting. So we are asking climbers to climb an easy task, to climb easy climbs, which is far below the skill level, and we expect this to induce boredom. And we ask them to climb a climb that is matched to their level. So this theoretically should induce flow. And we also send them up on climbs that are far above the skill levels, and we expect them to experience frustration. So I'm presenting the results of a pilot experiment that we are testing, where we are testing the result, this implementation of this paradigm. Oh yeah, before that, we also looked at dispositional flow in climbers. So they experience flow different. They have individual differences in experience of flow. And it's really interesting that trait emotional intelligence also predicts flows in climbers, because it means that the trait emotional intelligence that it predicted flow in musicians might have an effect beyond the fact that music is an emotional stimuli. So there is clearly a facility with managing your emotions also helps you to experience flow in another domain. So this might be a domain general trend. So no matter what the activity, a better ability to manage your emotions will help you better able to get into flow. So I call this in the wild because a flow is a flow experiment. It's a full experiment, but it's outside. So I go to the participants, I go to the climbers rather than they're coming to me into the lab. So we have 52 participants. I asked them to climb 3 easy climbs, 3 climbs matched at their levels, and 3 difficult climbs. So and we also had 2 different conditions. So in the first one, we asked them simply, what is your climbing level? And to figure out the most difficult climb, I asked them, what is the highest level you have climbed? And then I asked them to climb a climb that's way beyond that level. And in the second condition, I put into their mind the experience of flow. So I give them the 3 flow questions I gave you at the beginning of the slide, at the beginning of the presentation, and I asked them that, and I asked them if they felt that in climbing. And then I asked them, what is the climbing level that will most likely give you the feeling described? And again, what is the highest climbing level? So we did find a subjective difference. People responded on the flow scale after each climb. And it is interesting in that we aren't finding the U-shaped curve that we expected. So we are not finding the lowest scores in easy. In fact, I'm finding equal or even almost as higher scores in the easy conditions. So I'm seeing this linear decrease in flow experience rather than the U-shaped curve. When we looked at all the variables, it's all the same in all the flow subscales, which is a bit of a problem because they're not supposed to be experiencing highest flow in the easy condition, are they? So the only two subscales that seem to match their reports, so that match their report of experience flow, are the time perception when I made them think about flow, and their time perception showed that it was highest in the match condition, Whereas in the autotelic experience, it's the only thing that matched their idea of what they expect to experience flow in. So the autotelic experience, to recap, is the intrinsic reward, so how much they enjoyed the climb. So it is the highest in their flow conditions, in the match condition, rather than the difficult or the easy condition. So what does this mean? This is a little bit, this is all in preparation for a task for the situation of measuring flow outside the lab. So we have found that the challenge skill balance paradigm does not have quite what we expect. This could be because intrinsic motivation does throw off the relationship between challenge skill balance and flow. When people are enjoying something, they are far more likely to get into flow. So this is kind of the result. I found the same in musicians as well. So I never really got very low scores in musicians when they came into the lab, even when they told me they're not really experiencing flow. So this is something we need to think about in terms of the questionnaire and how we design the experiment. But it does give you somewhat more interest and somewhat more hope, I guess, that we are looking at flow as we kind of know it, rather than the flow that we are inducing in under lab circumstances. Because although we can enjoy playing computer games, it is probably not the same kind of intrinsic motivation that is involved in music or climbing, the things that people are passionate about. We also might be finding floor to ceiling effects. So for the easy condition, I made people climb the easiest climbs in the climbing center, but perhaps even those are not easy enough to induce boredom. And maybe the highest climbs for the really good climbers are also not enough to give you a proper frustration. So you might want to look at only a certain level of climbers that perfectly match the conditions inside the lab, inside the climbing center. But these are all factors that we have to think about, that when we are out in the wild where we can't control all the variables, but we are getting closer to that real experience of flow. So this is all work that we have to do to try to measure flow in the brain outside the lab. So this is all in preparation for an experiment where I'm trying to use a mobile EEG set to measure climbers as they climb.
So yes. I've got to interrupt there. Very interesting talk, Jasmine.
Thank you.
We have about 7 minutes for questions. So we've had some come in. Somebody's asked if we experience flow in these certain activities, can we actually use the activities to induce flow in people, which may help improve performance on that certain activity or even have any kind of therapeutic benefits? Do you have any opinions on that?
Yes, that would be an ideal. It is definitely been linked to increased well-being and better mental health, and it is something we are definitely looking to do. But obviously, there's a lot more research because it is not that easy to experience to induce flow just like that. I think it is really dependent on the person, and yeah, it is something I'm still really interested in figuring out as well for experiments.
Yeah, just to kind of add to that, I suppose having a kind of preference for that activity is going to influence whether you experience flow or not. Because if you like the activity, for instance, I often experience flow because I paint, and then when I'm painting, I experience it, but I enjoy painting. If you hate that activity or you don't get enjoyment from that activity, surely you're less likely to experience flow from it. So there must be some preference effect there.
Yes, intrinsic motivation is it's almost all associated with flow. So it's all about so flow is this state of highest intrinsic motivation. You're doing something that you enjoy the most. And it's funny that you mentioned painting, because we actually brought a painter into the lab, and she brought her own paintings, and she spent about 3 hours painting, and we measured her brainwaves in the lab. So it's not a full experiment. It was a bit of a pilot, but she told me she totally got into it, just even under lab circumstances. But that's kind of why it's so important. For the intrinsic motivation part makes it so important that we are actually measuring people in doing the activity they actually like, rather than the artificial case of Tetris or computer games or mental arithmetic.
That makes sense. So we've had a couple of questions about the kind of type of instruments that people have been playing while they've been in the lab. Have you had a variety of instruments that have been played, and how does that influence how you've used EEG? Because I also use EEG, and it's easy to record artifacts and get noisy data, and I can't imagine somebody playing an instrument while EEG is running. That must have been a challenge in itself. So did you have a variety of instruments, and how did that influence how you recorded your data?
Oh yes, definitely. I took everybody. So I took all kinds of instruments, violin. There are a lot of string players, a lot of wind players, singers, pianists. It was really interesting to find that it wasn't all that what I expected, because you would expect the pianists are easiest to collect data from because their instruments so far away from their head. But they move around a lot, so you got a lot of movement data. Singers, obviously you get the vibration all throughout their head, so that kind of threw things off. And violin players, especially because their head is towards their instrument, I picked the left side of their head would be picking up all the instrument vibrations rather than the brain activity. So we are experimenting with cleaning the data, seeing whether it's possible to find something related to brain data rather than instrument. But this is why it was so important to measure something that I could do for everybody, which is tell them to put their instruments down at the end of the playing and measure what they felt right after, as close to the experience possible, but right after, when they're not moving and they have their eyes closed, and it is completely, have perfectly clean data to look at from them. But yeah, it really depends on I think I'm finding it really depends on the head. I find that if you can really hit the cap well, even wind instruments, I could get very clean data while playing from, and we are definitely going to be looking at this data during playing data, and hopefully we'll find something.
Great, thank you. So we have a couple as well about kind of the comparisons between the two tasks that you've used. So you've used musicians and then climbing. We've had a lot of people kind of say about how climbing is obviously a physical activity, and also how there's a kind of physical threat to climbing, in the sense that you're high up, and if you fall, there's a potential danger to yourself, and whether that kind of anxiety or thrill and adrenaline from that could create a different kind of experience with flow than with musicians.
That is really interesting, because there is actually some research that shows that people need the threat to experience flow. So when we talk about flow in the challenge skill balance model, it is not exactly accurate, because yes, you experience flow when it's matched, but what they're finding is that it has to be matched and a little bit above your skill level. So you feel like you're being pushed, that you feel that you're stretching yourself, and that gives you the best flow experience of all. So so you almost need the threat, so that the not being completely safe. I think it helps climbers get in the flow better. But for musicians, the parallel is that I've heard many of them tell me, you should measure me when I'm performing, like in an actual performance where there's stakes involved. So when it's high stakes, I think they find that they almost get they're more likely to experience flow in front of an audience. So it'd be really exciting to be able to take a mobile EEG out to measure people outside in a real performance, I guess.
Yeah, you could probably even use that on, as you kind of mentioned, the real performance of musicians, maybe in front of an audience. Maybe that flow experience will be amplified by that kind of more adrenaline from having an audience in front of you. Do you think?
Yes, that would be really exciting.
Yeah, yeah. And you kind of answered the next question that I was going to ask. A couple of people have mentioned this idea of, there's the notion of people liking a challenge, and therefore maybe the group that you had it like below skill level, at skill level, and above skill level, maybe you could have flow in this above skill level as well, because of this idea of liking a challenge and pushing yourself. But I think you've mentioned that in your previous answer, where you said there's kind of an optimal level of having it above your skill.
And it's definitely the case where it gets a bit blurred. So when you there are at the higher levels, if you're looking at specific individuals, sometimes I found that they never ever experience frustration. Like no matter how difficult it is, they're still reporting like they're in the zone. They didn't want to come off the wall, so they're like, I'm not done. So there is definitely personality differences involved. There's a study that shows that they examined achievement motivation. So what kind of motivation you have. The people who want to achieve something, they want to be challenged, they are more likely to experience flow, especially when it gets harder.
I think we have time for one more question. So do you think have you compared, or do you think that the neurological relationships between flow can differ between the different activities? So the flow that is experienced in musicians, is that going to be neurologically different to the flow that is experienced when people read a book and experience flow, or do painting and experience flow, or do climbing and experience flow?
Well, that's the most interesting question of all, and we don't have the data yet, so it is somewhat optimistic that in flow during mental arithmetic, I have found some similar results in flow in musicians, and over a lot of activities, it has been reported in very similar terms, so people report feeling the same, and of course, different activities activate your brain differently, so. But after accounting for that, it would be really interesting to see if they actually still experience the same thing and is reflected in the neurological signals. But of course, we are still collecting data for that.
That's great. I think that is our time up, but thank you very, very
much. Thank you.
That was really interesting. Thank you.
Thank you.